Hi guys, welcome back. In this video we're going to talk about positioning in CSS, which can be a tricky topic. It definitely had me confused when I first started learning CSS, so hopefully here this will clear things up a little bit and you can pick up some useful little tricks. It's a simple idea really. The CSS position property allows us to define where element boxes are going to be on the web page relative to their usual starting position or relative to their parent element or other elements. So we're going to discuss the position property in this video and the 5 main values it has: static, relative, absolute, fixed and sticky positioning. And we'll also take a look at element visibility, so showing and hiding elements, etc., Z indexes, content overflow and offset properties. Okay, so the position property can have 5 values. It can have static, relative, absolute, fixed and sticky values. But before we look at these 5 position types, we're going to need to learn about the containing block. And the containing block is most often the content area of an element's nearest block level ancestor, but this is not always the case. Normal document flow is where elements are rendered according to their default display value and are stacked in an ordered way from top to bottom. In normal document flow, the root HTML element is the containing block for the body element, and the body element is the containing block for the top level elements on the web page, and each of these are the containing block for their children, and so on. But some values of the position property take elements outside the normal document flow. As such, what an element's containing block is depends on the value of the position property. So we'll look at some of those values now and make sure we understand what the containing block is, and this is going to help us understand how certain values position elements in particular ways. So we'll start with static positioning, and this is how every element is positioned by default. And later on, we will look at what we call offset properties of top, right, bottom, and left, and a concept called Z-index. When position is static, these properties have absolutely no effect on an element. Other than static, the simplest of the positioning schemes to understand is relative positioning. And so quickly, relative positioning is where an element is positioned according to the normal flow of the document and then is offset relative to itself, to its initial position on the page. Nothing happens until we use one of the offset properties to offset it. When a relatively positioned element is offset, other elements are not affected at all. Space is left behind, the same as if the position were static and the element was still occupying the space. Relatively positioned elements can be shifted with the offset properties of top, right, bottom, and left. These properties offset from the named side of the containing block. So left 10 pixels describes an element offset by 10 pixels from the left. Not moving the element 10 pixels to the left, but 10 pixels offset from the left side. So let's give our div a top of 75 pixels, and we see it is effectively pushed down from its original position by 75 pixels. If we say left 75 pixels, it shifts from the left by that amount. Positive values, as we see, move the element away from the named side, but negative values move the element to the named direction. So if we say left minus 75 pixels, it moves the element towards the left. Relatively positioned elements leave space where the element was before being positioned. Other elements act as if it's still in its original position. We also see that when a relatively positioned element is shifted, it overlaps other content. We could change top to minus 10 pixels and left to 225 pixels, and we see that the blue div now overlaps content in divs 3 and 4. If I make the div slightly less opaque, you can see that more clearly. So these are the 2 things that you need to be mindful of when using relative positioning: that the space that the element would ordinarily occupy is preserved, and that other content can be overlapped. When you have such an occurrence where 2 elements try to exist in the same place and overlap, we need to think about how we control which element is on top. And this is where the z-index property comes in. The order that elements stack is determined fairly simply. Those that come lower in the HTML document will overlap those that appear higher when they find themselves stacked. Z-index lets you alter this behavior. It takes its name from the coordinate system in which the horizontal plane is the x-axis, the vertical is the y-axis, and we see these on graphs and bar charts, for example. And the third axis, which makes it three-dimensional, runs from back to front, is called the z-axis. So our web pages are not just flat with height and width, but they can have depth also. Any integer can be used as a value for z-index, including negative numbers. An element with a higher z-index value is going to be put further forward than those with lower z-index values. This will cause the high value element to overlap the others. The default z-index value of all of the elements to begin with is auto, which actually corresponds to 0, where no z-index is explicitly assigned. An element with z-index 1 will then overlap all others with no z-index assigned. Another element with z-index of 2 will overlap that and all others, and higher numbers will then in turn overlap that, and so on. We can also use negative numbers, so an element with z-index -1 will be placed behind all other elements on the page that have no z-index assigned or a z-index of 0 and higher. There is no particular need to have the z-index values be contiguous. You can assign any integer of any size. If you want to be fairly certain that an element remains in front of everything else, you can just give it a silly high number like z-index of, say, 100,000. Okay, so let's look at absolute positioning. When an element is positioned absolutely, it's completely removed from the document's flow. It is then positioned with respect to its containing block. We really need to know the container's position more than the elements. So for an element to be able to position itself, it has to know which ancestor it's going to position itself relative to. This is the element's closest ancestor element that has a position value of anything other than static. Okay, so I've got a new pen here to focus on absolute positioning. Just 4 divs that are coloured differently with some padding applied to create a little bit of space to work in. Each div is labelled with some basic text. I've also made the body element black to differentiate it from the root HTML element, which is represented by this white area here around the black body. We know by default that our elements all have a position of static to begin with. So if we set position absolute on div 4, and we'll also have a top of 0 and the left 0, then we see that the element goes right to the top of the page. And this is because it's looking for elements that are not positioned statically. It goes and asks its direct parent, div 3, what position it is. Static, never mind. Then it asks div 2, you're static as well, never mind. Div 1 is static too. Okay, then the body element it will look at next, and that is also static. So as there are no possible ancestors here that fit the bill, then our element uses the initial containing block, which is the root HTML element. Its final position is then determined by the offset values, top, right, bottom, and left. So we've set top 0 and left 0, and we can change the position in relation to the root HTML element. So offset from the left 50 pixels, or offset from the top, let's say -60 pixels, which begins to drag the element up and above the containing element, as you see. But if we want to change the containing element, we want to offset and position the element from absolutely. As I said, we just need to pay attention to what this element considers its containing block to be. As all these elements are statically positioned by default, it disregards them totally. So we can change an ancestor or parent element's position value to anything, and this absolutely positioned element will recognize a new containing block. So let's set top and left back to 0 again to avoid confusion as to what the containing block is when we change it, and we'll set div 3 to position relative, thereby making it the containing block for the absolutely positioned div 4. We can change the selector to give the position relative to each of the divs, and when we do, the absolutely positioned element positions itself in relation to the element with the value that is not static, even all the way up to and including the body element. If we have more than one ancestor element that has a position other than static, it will position itself relative to the one that's closest to it. So we'll give relative positioning to div2, and div4 now looks up at div3, which is static. Not going to use that as the containing block. It looks at div2, you're not statically positioned, and I'll base my position relative to you. So that's it in a nutshell. An absolutely positioned element looks up the document through its ancestor element, starting with its direct parent. It's looking for an element that is not positioned statically. It will keep looking up until it finds one. If it fails to find one, it will fall back to using the root HTML element, which is the initial containing block. We can then use offset properties to adjust the final position of the element. An absolute positioned element does not flow around the content of other elements, and nor does their content flow around the absolute positioned element. This implies that an absolutely positioned element will overlap other elements or be overlapped by them, as we see here. So again, we could use the z-index property to control stacking order. Unlike relatively positioned elements, whatever space the element might have occupied in the normal document flow is closed up as though the element did not exist. It's hard to see with our green div here, but I'll put a span around this text in div 3 and set styles to the span. We'll give it a different color. Let's set a top of 100 pixels, and we'll also set left 150 pixels. That does nothing on this statically positioned element, but when we set position absolute to the span, the text in the span is taken out of the normal flow, and the space that it has left behind closes up. It puts it way up to the top, so if I uncomment the relative positioning on div 2, then both div 4 and this span are going to position themselves relative to div 2's position. And again, we see that the span text is removed from its normal flow and does not leave space behind when it is positioned absolutely. Okay, so we'll stay here in this pen now and look at content overflow. So if the content of an element is too much for the element size, it's going to be in danger of overflowing the element itself, spilling out into other areas of our web pages, and we don't want that in areas where it shouldn't be. There are a few alternatives in such situations, and CSS lets you select between them. It also allows you to define a clipping region to determine the area of the element outside of which these sort of things become an issue. So let's say that we have, for whatever reason, an element that's been pinned to a specific size and the content doesn't fit inside it. Let's take a look at our div 4 again. We'll give it some height and width, and we'll also take the padding off, and we've also got black text that will not look good against the black body, so we'll make this text white. If we now go to the element in the HTML and add 100 words of lorem ipsum, we see exactly what happens. The text has broken free of the height and width constraints that we've given to the element, and we're overlapping other content as expected. We can take control of the situation with the CSS overflow property, and overflow can have 4 possible values, and these are visible, hidden, scroll, and auto. The default value is overflow visible, which is what we have here with this element. This means that any content overflowing outside the element is going to be visible. The overflow hidden property clips the content at the edges of the element box, and whatever is outside of the constraints that we set is not going to be shown. So with our height and width properties set like so, we're going to lose some of the text, which might possibly contain information that we actually need to show on the web page. So this is not an ideal solution. So overflow scroll is probably going to be better for us, and this clips the element's content just the same as the hidden value, but makes content that is initially hidden accessible via a scroll functionality, which includes this scroll bar here at the side. Unfortunately, the scroll bar is going to sit on top of the content, so you'd need to take this into account and probably add a little bit of padding if you're going to use it. Auto has a similar effect to scroll really, and the difference is that instead of explicitly stating what you need, you're allowing the browser to determine the overflow behavior that it's going to use. Of course, here the browser is determining that the content is overflowing its container and is going to need to be scrolled. Okay, so let's look next at fixed positioning. We've seen static, relative and absolute so far, and fixed positioning is just like absolute positioning really, except the containing block of a fixed element is actually the viewport rather than the nearest ancestor that has a position other than static. So our div4 has an absolute position currently and is positioned relative to the nearest container with a value other than static, and that is this div2 which is set to position relative. If we change div4 top to 0 and left to 0, and we'll set position to fixed, we see that it jumps right to the top of the viewport. It's totally removed from the document's flow here and does not have a position relative to any element or any part of the document. It does not take the document into consideration at all. All it's doing is fixing itself relative to the viewport, which is the user's visible area of a web page. So this whole area. We can use offset properties, of course, to move it around. Another use for fixed positioning is to place a persistent element on the screen, like a navbar with a list of links. So let's change div4 back to relative positioning, and we'll create a nav element in the HTML with a list of 3 items that we could drop links into later on. I'll give it a purple background color in the CSS, and we'll also give it an opacity of, let's say, 95%, so we can see what is going to be happening underneath it. We can, of course, lay this out horizontally, this list, and remove all the bullets and add some A tags inside, align them all to the right so they appear as a set of links that you would typically see in the navigation bar on a normal web page, but I'm going to skip that here as I'm just showing you how to fix the nav bar to the top persistently. So I'll set a position fixed, and then we'll have a top 0 and a left 0, and we see that when we do that, the navbar attaches itself to the top of the viewport, and we're going to want to stretch this the full width, so we'll also say width 100%. Now when we scroll, the nav stays fixed at the top and the other elements scroll, but we do have this weird behavior here where some of the divs are overlapping, so we'll give the nav a z-index of 1, which is higher than anything else that we've currently got, so it comes to the front of the page and is going to sit on top of these other elements, and they will now scroll underneath. You have to remember that other elements don't care that it's there and will sit in their ordinary position. Fixed positioning is just ripping the element out from the document and attaching it to the viewport. So if this bit of the body element that is being overlapped was, it needed to be seen, then you'd have to give whatever element that you had here some top margin, perhaps to bring it down below the nav. We could also use fixed positioning to create things like pop-up modals that you see that will sit on top of everything and have to be clicked to make them disappear and things like that. You see them on newspaper websites that are asking you to subscribe or telling you that you have only a certain number of articles left to view that month. Okay, so lastly, we're going to look at sticky positioning, and the element is left in the normal flow until the conditions that trigger its stickiness come to pass, at which point it's removed from the normal flow, but its original space in the normal flow is preserved. It will then act as if absolutely positioned with respect to its containing block. Once the conditions to enforce stickiness are no longer met, the element is returned to the normal flow in its original space. Offsets of top and left, etc. are used to define a sticky positioning rectangle with relation to the containing block. So we'll change the nav to position sticky, and now I'll just duplicate these div elements a couple more times so that we have a really long scrollable page. Now when we scroll, we see that the sticky nav sticks to the top of the page when the top edge of the element hits it, which is pretty cool. And when we scroll its original position back into view, then the nav repositions itself there. Before we stop, actually, we'll look at element visibility because it affects positioning, and possible values for the CSS visibility property are visible, hidden, and collapse. And this one is pretty easy. If an element is set to have visibility visible, then it is, as you might expect, visible on the screen. That's the default behavior, and we'll set that here to this nav to show it. If an element is set to visibility hidden, then it's made invisible, to use the exact wording used in the CSS specifications. In its invisible state, we see the element still affects the document's layout. The other elements act as if it's still there. The space for the nav is still there, and it's acting as if we've basically just declared opacity of 0. Everything visible about a hidden element, such as content, background and borders, is made invisible, and the space is still there because the element is still part of the document's layout. We just can't see it. Note the difference between this and when we set display none. In the latter case, the element isn't displayed, just like with visibility hidden, but it is totally removed from the document altogether, so that it doesn't have any effect on the layout of elements around it. It's possible to set the descendant element of a hidden element to be visible, and this causes the element to appear wherever it normally would on the page, even though the ancestor is invisible. So to do so, we explicitly declare the descendant element as visible, since visibility is inherited. We now see that those links are visible despite the nav itself being hidden. Okay, so that covers positioning in CSS. Thanks to the position element, it's possible to move elements around in ways that the normal flow couldn't accommodate. So we've seen the 5 values of the position property and their behaviors and uses, and we've seen the Z index, content overflow, and we looked at element visibility as well. Although many positioning tricks that are shown here give way to flex and grid layouts these days, there's still a lot of uses for positioning. Nav bars that stay fixed to the top of the page are one example that we've seen here. Combined with the stacking possibilities of the Z axis and the various overflow patterns, then the CSS positioning property is still really useful, and we need to know how to use it. So thanks for watching. I do appreciate your time. Remember to like, sub, and all of that stuff, and I will see you in the next one.